Hello and welcome to Boring Planet. I'm glad you found your way here. Wherever you are, let this be a moment where nothing needs your attention and nothing needs to be solved. Tonight, we're staying close to the ground on a planet that has been quietly carrying life for billions of years without ever asking to be noticed. Earth moves slowly, patiently, shaping itself through water, stone, air, and time, doing most of its work far beyond our awareness. From oceans that sometimes glow in the dark to creatures that quietly outlast generations, from forests connected beneath the soil to life thriving in places that seem almost impossible, this planet is alive in ways that don't demand excitement, only presence. Some of what you hear tonight may gently change how you picture the world around you. Other parts may drift past without leaving a trace, and that's perfectly fine. This isn't about remembering facts, but about letting your thoughts soften as the story unfolds. If this kind of calm curiosity feels comforting, you're always welcome to return, or to share it with someone else who might need a quiet moment too. But for now, get comfortable. Let the day fade into the background and allow the planet to speak in its own unhurried way. Even when Earth looks still, it is never at rest. The quietest landscape you can imagine, a flat plain, a frozen lake, a desert stretching to the horizon, is part of a system that is always moving, always exchanging, always adjusting itself in ways too slow or too large for us to notice in a single moment. What we call stillness on this planet is usually just motion, happening on a scale that doesn't ask for our attention. Air drifts invisibly from places of warmth to places of cold. Water lifts itself into the sky molecule by molecule, travels vast distances without a sound, and returns as rain or snow, not because it intends to, but because the physics of Earth make it inevitable. Rock itself, which seems like the definition of permanence, bends, cracks, melts, and reforms when given enough time. None of these processes act alone. They are linked, braided together into cycles that overlap and feed one another, creating a planet that behaves less like a stage where events occur and more like a body maintaining balance. Earth does not move in straight lines. It moves in loops. Carbon drifts from air into leaves, from leaves into soil, from soil into stone, and sometimes back into the sky through fire or breath. Water slides from ocean to cloud to mountain to river and back again, repeating a journey it has taken for billions of years without ever retracing the exact same path. Even energy itself cycles, arriving from the sun in steady waves, warming the surface, driving winds and currents, then radiating back into space. Nothing is truly wasted. Nothing is isolated. Each part of the system leans gently on the others, and when one shifts, the rest respond, not instantly, but persistently, until a new balance forms. This is why Earth can appear calm even after enormous change. When a volcano erupts, it feels violent and sudden, but volcanism itself is part of a long-term cooling process. The planet releases heat from its interior slowly through cracks and seams, like a pressure valve easing itself open over millions of years. Lava hardens into rock, rock breaks down into soil, soil supports plants, plants alter the air influences the climate shapes where life can exist. Each step flows into the next, not by design, but by consequence. It can be tempting to think of Earth as fragile, but fragility implies something that cannot bend without breaking. Earth bends constantly. It has survived impacts large enough to reshape continents, periods where most life vanished, eras when ice covered nearly the entire surface. Each time, the system reorganized itself, slower than panic, faster than stagnation. balance on this planet does not mean stillness. It means movement that never quite stops. Even the ground beneath you participates in this exchange. Soil is not just dirt. It is a living boundary where rock, water, air, and life meet. Mineral grains weathered from stone mix with decaying plant matter, microbes, fungi, insects, and roots, forming a layer that breathes in its own way. Gases move through it. Water filters down and rises again. Nutrients are borrowed, released, reused. When soil is healthy, it holds water during dry periods and releases it slowly when rain returns. It buffers extremes. It remembers what has grown there before and shapes what can grow there next. This memory is not conscious, but it is real, written in chemistry and structure rather than thought. The same is true of the atmosphere. It feels empty, but it is dense with motion. Winds circle the globe in looping patterns, driven by the uneven heating of Earth's surface. Warm air rises, cool air sinks. The planet's rotation bends these flows into spirals, creating trade winds, jet streams, and long wandering currents of air that connect distant regions. A dust storm in one continent can fertilize forests on another. Moisture lifted from a warm ocean can fall as snow thousands of kilometers away. The atmosphere is not a shell. It is a moving ocean of gas, constantly stirred by the planet beneath it. And beneath both land and air, the oceans perform their own quiet labor. Covering most of the planet, they absorb heat, store it, move it, and release it slowly, smoothing out extremes that would otherwise make Earth far harsher. Currents flow like immense conveyor belts, carrying warm water toward the poles and cold water back toward the equator. These movements happen whether we notice them or not, guided by temperature, salinity, and the shape of the seafloor. In the depths, water sinks and rises on timescales measured in centuries, meaning that some of the water moving beneath the surface today began its journey long before modern civilizations existed. The ocean remembers. It holds dissolved gases, nutrients, and heat, exchanging them with the air above in a slow conversation that never ends. This is why Earth can be thought of as breathing, not in the sense of lungs or intention, but in rhythm. Carbon dioxide rises and falls, oxygen accumulates and is consumed, heat is taken in and released, the planet inhales energy from the sun and exhales it back into space. Forests thicken and thin, ice advances and retreats, deserts expand and contract. These are not signs of instability, they are signs of a system alive with feedback, constantly adjusting itself in response to internal and external changes. Even life itself is woven into these cycles rather than sitting atop them. Plants don't merely occupy Earth's surface, they actively shape it. Roots break rock apart, leaves slow rainfall, allowing water to soak into soil instead of rushing away. Forests influence cloud formation by releasing moisture into the air. In some regions, large ecosystems help create their own climate, recycling rain again and again before it ever reaches the sea. When these systems are disrupted, the effects ripple outward, not because Earth is delicate, but because interconnected systems respond collectively. Animals play their part as well, moving nutrients across landscapes, stirring soil, shaping vegetation through grazing and movement. Microorganisms, invisible to the eye, drive much of this exchange, transforming elements into forms that other life can use. Without them, the cycles would stall. With them, the planet hums along quietly, recycling the same materials endlessly in new arrangements. It's easy to miss this living quality because it doesn't announce itself. Earth doesn't pulse or glow or signal when a balance is restored. It simply continues. Even decay is part of this persistence. When something dies, it does not leave the system. It dissolves back into it, becoming soil, gas, mineral, energy. Nothing is expelled, everything is transformed. This is why the planet feels so deeply ancient. The atoms that make up mountains once drifted in stars. The water in oceans has been part of comets, clouds, glaciers, and blood. The air has passed through countless lungs and leaves. Earth is not made of new materials, it is made of recycled ones, rearranged over and over into new forms. That continuity gives the planet a kind of quiet authority. It has seen every version of itself and persisted through all of them. When you think of Earth this way, as a system rather than a backdrop, its calm begins to feel contagious. There is no rush in these cycles, no deadline they're trying to meet. They operate because conditions allow them to, and they adjust when those conditions change. The planet does not resist change. It absorbs it, distributes it, and settles into new patterns. Even when those patterns take thousands or millions of years to form, Earth is patient enough to wait. That patience is not passive. It is active balance, a constant negotiation between forces that never fully cancel each other out. And as this negotiation continues, life finds spaces to exist within it, adapting not to perfection, but to motion itself. In that sense, Earth is not a machine running toward an outcome, and it is not a stage waiting for actors. It is a system in conversation with itself, endlessly responsive, quietly resilient. And whether we are paying attention or not, we are carried within that conversation, moving with it, balanced by it, sustained by rhythms that began long before we arrived and will continue long after we are gone. The ground beneath you is older than almost anything you've ever known, and it carries its age quietly. It doesn't announce itself or try to impress. It simply exists, holding memory in a form that doesn't fade the way stories do. Every place on Earth, even the most ordinary patch of land, is part of a long record written slowly, grain by grain, layer by layer. Geological time doesn't hurry, and it doesn't measure itself in years the way we do. It measures itself in accumulation, in pressure, in the patient settling of particles that once drifted freely in water or air. When you walk across a field, a street, or a mountainside, you're moving across pages of a book that has been written continuously for billions of years, with no beginning chapter left intact and no final chapter planned. Long before the surface looked the way it does now, molten rock cooled and hardened into the first crust. That crust broke, folded, sank, and rose again, not once but countless times. What we call solid ground is the result of repeated cycles of creation and destruction, each one leaving traces behind. Rivers laid down sediments that hardened into stone. Oceans advanced and retreated, depositing shells, minerals, and microscopic remains that compressed into layers. Deserts formed, disappeared, and returned, their sands transformed into sandstone under the weight of time. Each layer stacked atop the last, preserving a moment in Earth's long memory, even as the world above continued to change. In some places, these layers are exposed, revealed by erosion or uplift, and you can see them clearly, stripes of colour running across cliffs or canyon walls. Each stripe marks a different environment, a different climate, a different chapter in the planet's story. What looks like a simple rock face is actually a timeline, showing when seas were shallow or deep, when forest thrived, when volcanic ash fell from the sky and settled quietly over everything. Even a single stone picked up from the ground carries this history within it. Its minerals crystallized under specific conditions of heat and pressure. Its shape was altered by water, wind, or ice. Its surface was smoothed or fractured by forces that no longer exist in quite the same way. Rocks don't forget where they've been. They carry chemical signatures that reveal their origins, traces of elements that tell scientists whether they formed deep within the Earth, at the bottom of an ancient ocean, or from lava flowing across a barren landscape. In this way, the planet keeps time without clocks. It remembers through matter. Landscapes themselves are expressions of this memory. Mountains are not static monuments, but records of collision and compression. When tectonic plates push against each other, rock crumples and thickens, slowly rising over millions of years. What we see as towering peaks are the visible result of pressures that acted far below the surface long before there were eyes to see them. Over time, those same mountains begin to wear down. Rain seeps into cracks, freezes, expands, and breaks stone apart. Rivers carry fragments away. Wind lifts grains of sand and moves them elsewhere. The mountain lowers itself, not suddenly, but steadily, returning its material to the wider system. Valleys deepen where water finds a path. Plains spread where sediment accumulates. The shape of the land is never final. It is always becoming something else. Even flat places tell stories. A wide, level plain might look timeless, but it is often the result of long erosion, where high ground was worn down and redistributed. Coastal areas record the rise and fall of sea levels, marked by terraces and ancient shorelines now stranded far from the water. Deserts preserve ripple marks frozen in stone, evidence of winds that once blew across open sand. Glaciers leave behind scratches on rock, grooves that point the direction of ice that moved long ago. These are not dramatic messages. They are subtle marks, easy to overlook unless you know how to look for them. Earth doesn't shout its history, it whispers it into the landscape. Time in geology stretches so far that it can be difficult to grasp. Human lifespans are measured in decades. Recorded history spans a few thousand years. But geological time extends back billions of years, covering periods so vast that entire species rise and vanish within what would be a single sentence in the planet's autobiography. Dinosaurs dominated the land for over 160 million years, yet their entire era occupies only a thin layer in the rock record. Before them came other creatures, stranger and less familiar, preserved as fossils in stone. Before those, life existed only as microscopic forms, leaving behind chemical traces rather than bones or shells. Even earlier still, the planet was shaped by forces that predate life itself, as Earth cooled, differentiated, and settled into the structure it has today. Fossils are among the most direct connections we have to this deep past. They are not bones magically turned to stone, but impressions, mineral replacements, and subtle chemical changes that preserve the shape of once living things. A leaf pressed into mud, a shell buried in sediment, a footprint filled with sand, all can become part of the geological record if conditions are just right. Over time, the original material decays, but the shape remains, locked into rock. These fossils don't tell stories in words, but they tell them in form. They reveal what lived where, and sometimes how it lived, moved, or died. They show us that life has always been intertwined with the planet's physical processes, adapting to shifting climates, changing oceans, and moving continents. Even the absence of fossils can be meaningful. Gaps in the record point to times when conditions prevented preservation, or when environments were too harsh for life to leave traces behind. Earth's memory is incomplete, but that incompleteness is part of its honesty. It records what it can, when it can, without trying to be comprehensive. Ice, like rock, also keeps time. In polar regions and high mountains, snow falls year after year, compressing into ice and trapping tiny bubbles of air inside. These bubbles are snapshots of ancient atmospheres, preserving the composition of air from tens or even hundreds of thousands of years ago. By drilling deep into ice sheets, scientists can read this frozen archive layer by layer, learning about past temperatures, greenhouse gas levels, volcanic eruptions, and even distant wildfires whose ash drifted into the snow. The ice remembers seasons the way tree rings do, recording cycles of cold and warmth with quiet precision. When ice melts, it releases that memory back into the system, not as information, but as water, continuing the cycle. Soil, too, holds its own kind of clock. Layers of soil build slowly as plants grow, die, and decompose, mixing with minerals weathered from rock. Different horizons form, each with distinct properties, reflecting long-term interactions between climate, organisms, and parent material. A fertile soil profile tells a story of stability and renewal. A thin or eroded one hints at disturbance or change. Even ancient human activity can be traced in soil layers where charcoal, pollen, or altered chemistry marks the presence of people long gone. The land remembers us, just as it remembers everything else, though it never assigns importance. In this deep view of time, the present moment becomes both incredibly small and strangely expansive. Small because it occupies such a tiny fraction of Earth's history. Expansive because it is the only moment where all that history converges into a living, breathing world. The ground beneath you is not just old, it is active memory, continuously rewritten by processes that began long before you arrived and will continue long after. When you rest on it, you are resting on the accumulated outcome of countless quiet changes, each one necessary, none of them hurried. Geological time doesn't demand attention, but it offers perspective. It reminds us that change is constant, that stability is dynamic, and that even the most solid things are part of a larger ongoing story. The Earth keeps its clock not by ticking, but by layering, folding, eroding, and rebuilding over and over again in a rhythm so slow it feels like stillness. And yet, within that stillness, everything continues to move forward, one grain at a time. Nothing on Earth is as fixed as it appears, and the sense of solidity we carry with us is mostly a trick of scale and time. The land feels stable because it moves so slowly that motion disappears into patience. But beneath that stillness, the planet is always rearranging itself. Continents drift the way massive ships drift across a calm ocean, not pushed by wind or intention, but carried by forces so gradual they become almost philosophical. Far below the surface, deep beneath rock and sediment and memory, Earth's interior still holds heat left over from its earliest days. That heat doesn't roar or surge, it circulates. Warm material rises, cool material sinks, and over millions of years these quiet currents move the rigid plates above them. The crust floats, not on water, but on a softer, slowly flowing mantle, and this floating is enough to move entire continents across the face of the planet. The distance covered in a single year is small, about the rate at which fingernails grow, but the distance covered over geological time is immense. Oceans open where land once stretched unbroken. Seas close where waves once rolled endlessly. Land masses that were neighbours drift apart, and strangers meet after journeys that last tens of millions of years. There was a time when most of Earth's land was gathered into a single supercontinent, a vast connected world known as Pangaea. Forests could spread across it without interruption. Rivers flowed for extraordinary distances. Animals could wander from what is now Africa to what is now North America without ever crossing an ocean. But that closeness did not last. Heat built beneath the crust, stress accumulated, and eventually the continent cracked. Not suddenly, not catastrophically, but slowly, along weaknesses that deepened over time. Rifts formed, magma rose, new crust hardened, and gradually Pangaea loosened its grip on itself, breaking apart into the continents we recognize today. The Atlantic Ocean began as a narrow seam, a widening scar where land pulled away from land. Even now it continues to widen, centimetre by centimetre, carrying continents farther apart without noise or urgency. Where plates move away from each other, new crust is born. Where they collide, something else happens. When one plate presses into another, the crust has nowhere to go but up or down. Sometimes one plate slides beneath the other, sinking slowly back into the mantle, carrying sediments and water with it. Sometimes neither plate yields easily, and instead the crust crumples, thickens, and rises. This is how mountains are made, not thrust upward in a single dramatic moment, but folded like fabric under steady pressure. The Himalayas are still rising today, pushed upward as India continues its long collision with Asia, a meeting that began tens of millions of years ago and has not yet finished. Each year, the mountains grow a little taller, even as erosion works to wear them down. Growth and decay happen at the same time, balanced in a slow exchange. Other mountain ranges tell similar stories. The Andes trace the edge of South America where oceanic crust sinks beneath continental land. The Rockies remember a period when plates interacted differently than they do now. Even ancient, worn-down ranges carry the memory of collisions long past, their peaks softened by time but their roots still deep and thick beneath the surface. Continents also slide sideways, grinding past one another along faults where motion is horizontal rather than vertical. These boundaries are quieter most of the time, marked by subtle tension rather than obvious change. Stress builds gradually, locked into rock until it is released in brief moments we experience as earthquakes. Even these events, sudden as they feel, are part of the same slow dance. Plates catch, strain, and slip, adjusting themselves in increments. The planet is not breaking when this happens. It is relieving pressure, redistributing energy, continuing its long habit of movement. The edges of continents are often where this motion is most visible, but the interiors are not truly still either. Old faults remain. Ancient collisions leave scars deep in the crust. Even regions we think of as geologically quiet carry the structural memory of past movement, like muscles that remember old injuries. Landscapes inherit their shapes from these deep processes. Coastlines follow the outlines of continental margins shaped by rifting and collision. Island chains rise where plates meet in particular ways, marking zones of melting and uplift. Volcanoes trace lines that map the invisible boundaries below. None of this is random. It is the surface expression of forces that operate continuously, even when nothing seems to be happening. If you could speed time up enough to watch continents move, the motion would look smooth and deliberate, not jerky or chaotic. Land would slide, rotate, collide, and separate with a strange elegance. Oceans, opening like slow breaths and closing just as gently. The planet would look alive in a way that has nothing to do with biology. It would look like a system adjusting itself, redistributing heat, mass, and stress in pursuit of balance, even though balance itself is never fully reached. This motion has shaped the distribution of life as well. As continents drifted, climates changed, Currents shifted, species were carried apart or brought together. Isolation led to divergence, connection led to competition and exchange. The slow rearrangement of land guided evolution without intention, simply by altering the stage on which life unfolded. Forests spread, retreated, and returned elsewhere. Deserts formed in the rain shadows of rising mountains. Ice accumulated when continents drifted toward the poles and melted when they moved away. All of this happened gradually enough that life could respond, adapt, and continue, even as the ground beneath it wandered. To stand on a continent today is to stand on something that has travelled farther than any human ever could, carried not by wheels or engines, but by the quiet persistence of heat and pressure deep below. The place you are now was once somewhere else entirely, closer to the equator or nearer a pole, wetter or drier, warmer or colder. The stars overhead have shifted too, though we rarely think of that, as Earth's position in space changes alongside its internal motion. Nothing about the planet is frozen in place. It is all in transit, all the time, just slowly enough to feel eternal. This drifting does not aim toward an endpoint. There is no final arrangement waiting to be achieved. Continents will continue to gather and separate. Mountains will rise and fall. Oceans will appear and disappear, as long as the planet retains heat and gravity holds everything together. What feels like permanence is really continuity, a long, unbroken process unfolding without haste. And as this motion continues almost imperceptibly, it carries with it everything built on the surface, rivers, forests, cities, and lives, moving them together through deep time, whether they notice or not. A river doesn't rush, it simply keeps going, and in doing so it becomes one of the planet's most patient writers, tracing lines across the land that last far longer than any map or memory. Water has no plan, no destination it's trying to reach quickly, and no preference for drama. It moves because gravity allows it to, following slopes so slight they're often invisible, responding to the smallest differences in height and resistance. What looks like intention is really persistence. A single drop of rain landing on a hillside does not know it will one day reach the sea, but given enough time and enough companions, it will. Rivers begin quietly, often as thin threads of water slipping through soil and rock, gathering strength as they accept contributions from countless tiny streams. Each addition changes the river's character slightly, widening it, deepening it, giving it more energy to shape the land it passes through. The work is slow, but it never stops. As water moves, it lifts grains of sand, nudges pebbles, dissolves minerals, and carries them away. What it cannot move, it flows around. What it flows around, it gradually reshapes. Over long spans of time, this gentle persistence carves valleys that seem impossibly large compared to the modest force of flowing water. The Grand Canyon, with its towering walls and immense depth, was not created by a sudden event, but by the steady action of the Colorado River, cutting downward over millions of years as the land itself slowly rose. The river did not hurry to make the canyon, it simply kept pace with the uplift, removing material as it was exposed, maintaining its course through changing conditions. Many rivers behave this way, adjusting their paths in response to subtle shifts in the land. When the ground tilts, the river responds. When sediment builds up, the river reroutes itself. Meanders form not because rivers wander aimlessly, but because flowing water naturally erodes the outer edges of bends where velocity is higher, while depositing sediment along inner curves where the current slows. Over time, these bends exaggerate themselves, looping farther and farther until a shortcut forms, and the river abandons its old curve, leaving behind an oxbow lake as a quiet reminder of where it once flowed. These shapes are not random decorations on the landscape. They are signatures of efficiency, the river constantly adjusting its route to expend the least amount of energy while moving the greatest amount of water and sediment. In floodplains, rivers spread out during periods of high flow, depositing layers of fertile silt that enrich the soil. This process has supported ecosystems and human civilizations alike, not through generosity, but as a side effect of physics. When water slows, it drops what it carries. Over centuries, these deposits build broad, flat plains that can sustain dense plant life. At river mouths, this process becomes even more pronounced. As rivers meet the sea, their current slows dramatically, releasing vast amounts of sediment that settle into deltas. These branching networks of channels look like living things from above, constantly rearranging themselves as water and land negotiate their boundary. Deltas grow outward, inch by inch, claiming space from the ocean, even as waves and tides work to reclaim it. This balance between river and sea is never final. Channels shift. Landforms appear and disappear, yet the overall structure persists, shaped by the ongoing conversation between fresh water and salt. Rivers also serve as connectors, linking distant parts of the landscape into a single system. A storm falling in the mountains can influence water levels hundreds or thousands of kilometers away. Snowmelt carries nutrients from high elevations to lowlands, feeding wetlands and estuaries far from its origin. Even dissolved minerals transported by rivers eventually enter the ocean, where they influence chemistry, biology, and the formation of new sediments on the seafloor. In this way, rivers act as translators between solid land and moving water, converting rock into sand, sand into soil, and soil into nourishment for life. They are not just features on the surface of the planet, but active participants in its cycles. The shapes rivers carve also reflect the history of the land they traverse. A steep, narrow valley suggests a young river cutting into recently uplifted terrain. A wide, winding channel hints at an older landscape where erosion has had time to soften slopes and broaden floodplains. In places where rivers encounter resistant rock, waterfalls may form, stepping the river downward as it continues its work upstream through erosion at the base of the fall. Over time, even these obstacles retreat, migrating backward as rock is worn away. Nothing about a river's path is fixed forever. It is always responding, adjusting to changes in climate, vegetation, and tectonic movement. During wetter periods, rivers may cut deeper channels. During drier times, they may deposit more sediment, filling their own beds. Ice ages alter their flow patterns entirely, as glaciers dam valleys, redirect channels, and release enormous floods during melting phases. The scars of these events remain etched into the land long after the water has returned to quieter patterns. Human history has often followed rivers for this reason. They offer water, fertile land, transportation, and a sense of continuity. Cities rise along their banks, ports develop at their mouths, and cultures orient themselves around their seasonal rhythms. Yet even where rivers are constrained by levees, dams, and channels, they retain their underlying tendencies. Water still seeks the easiest route. Sediment still accumulates where flow slows. Floods still occur when volume exceeds capacity. Attempts to fully control rivers often reveal just how persistent their behavior is. They adapt around obstacles, sometimes patiently, sometimes abruptly, but always according to the same principles that guided them long before human intervention. To watch a river closely is to witness time made visible. The water you see passing by is never the same from one moment to the next. yet the river itself remains. It is continuity without sameness, motion without haste. Each drop participates briefly before moving on, contributing its energy to a larger flow that will continue regardless. In this way, rivers mirror many of Earth's deeper processes, not dramatic, not static, but endlessly active within narrow constraints. They show how great change can arise from small forces applied consistently, how landscapes can be shaped without intention, and how persistence can outlast resistance. As rivers continue their slow journeys, they carry with them the memory of the land, dissolving, sorting, and redistributing it, line by line, across the surface of the planet, quietly extending the story written by moving continents and layered stone, always onward, never in a hurry, always becoming something slightly new. In the dark, the earth makes sculptures one drop at a time, working patiently in places most of the world never sees. Long after rivers have traced their paths across the surface and continents have inched their way across the planet, water continues its quieter journey downward, seeping into cracks so small they're barely more than suggestions. Rainwater absorbs carbon dioxide from the air and soil, becoming slightly acidic, just enough to begin dissolving certain types of rock, especially limestone. This doesn't happen quickly, and it doesn't happen everywhere. But where conditions are right, the process continues year after year, century after century, until voids open beneath the surface. At first, these spaces are no larger than widened fractures, but over time they grow, linking together into hidden corridors and chambers. Caves are not carved with force, but with persistence, formed by water that never rushes and never tires, following paths laid out by the planet's own structure. Inside these underground spaces, the pace of change slows even further. Water drips from ceilings at intervals that can stretch from seconds to minutes, sometimes even longer, and each drop carries a tiny amount of dissolved mineral. When it falls, carbon dioxide escapes, and the mineral is left behind, a thin residue that clings to the rock. Over thousands of years, this residue accumulates, forming stalactites that hang downward like stone icicles, and stalagmites that rise from the floor to meet them. They grow so slowly that a human lifetime barely registers in their progress. A centimetre might take decades or centuries to form, depending on conditions. In some caves, the shapes are delicate and needle-like. In others, they swell into thick columns where ceiling and floor have finally joined. Each formation records the chemistry of the water that built it, layer by layer, preserving changes in climate and rainfall long after they've passed. The silence in caves is different from silence above ground. It isn't empty. It's insulated, wrapped in stone that absorbs sound and holds temperature steady. Deep underground, seasons fade away. Summer heat and winter cold lose their meaning, replaced by a near constant coolness that reflects the average temperature of the region above. This stability allows caves to act as archives, not just of rock, but of time itself. In some caves, thin layers of mineral deposits can be analysed much like tree rings, revealing shifts in rainfall patterns, droughts, and even ancient storms. The cave remembers what the surface forgets. Life, too, adapts to this darkness. Some creatures spend their entire existence underground, evolving without eyes or pigment, navigating by touch and vibration instead. Others visit caves only briefly, bats roosting in vast colonies that fill chambers with the soft rustle of wings and the faint warmth of bodies pressed together. Over generations, the presence of these animals alters the cave environment, adding nutrients through waste and remains, feeding microbial communities that would otherwise struggle to survive in such an isolated place. Even here, far from sunlight, Earth systems continue to interlock, finding ways to recycle energy and matter. Caves can form in other ways as well. Lava flows sometimes leave behind tunnels when the outer layer cools and hardens, while molten rock continues to drain away inside, creating smooth-walled passages that snake beneath volcanic landscapes. In coastal regions, waves exploit weaknesses in cliffs, hollowing out sea caves that fill and empty with the tide, echoing with the sound of water moving through stone. In icy regions, glaciers carve tunnels beneath themselves, channels of meltwater that shift and collapse as the ice above flows onward. Each type of cave tells a slightly different story about the forces that shaped it, but all share the quality of being hidden, removed from the rapid changes of the surface world. For humans, caves have long held a sense of mystery and shelter. Early people used them as homes, gathering places and canvases, leaving behind handprints, animals and symbols painted on stone walls tens of thousands of years ago. These markings remain vivid in places where air movement is minimal and light rarely reaches, protected by the same stillness that preserves mineral formations. To step into such a cave is to share space with minds from deep history, separated by time but connected through the same quiet stone. Caves have also served as refuges for species during periods of extreme climate, offering stable conditions when the surface became hostile. During ice ages, caves sheltered animals and plants at the edges of advancing glaciers. During dry periods, they held pockets of moisture that sustained life. In this way, caves act as buffers, small pockets of consistency in a world of change. They do not resist the planet's cycles, but they soften their effects, providing continuity amid transformation. The air inside caves moves slowly, often driven by subtle differences in temperature and pressure between entrances. This gentle circulation shapes where formations grow, where moisture collects, and where life can persist. In deeper sections, air may be nearly still, allowing dust to settle and sounds to fade quickly. A single footstep can echo and then vanish, swallowed by the rock. Over time, this absence of disturbance creates an environment where even small changes become significant, where a single drip can leave a mark that lasts for millennia. The idea of Earth creating bedrooms for itself is not meant to suggest rest in a human sense, but rather protection and patience. Caves are places where the planet tucks away parts of its surface, insulating them from erosion and weather, allowing processes to unfold without interruption. While rivers rush overhead and winds scour exposed rock, caves remain mostly unchanged, continuing their slow work regardless of what happens above. Floods may temporarily fill them, earthquakes may shift their shapes, but even these events become part of the long record etched into their walls. Minerals fracture, reform, and settle again. New passages open, old ones collapse. The cave evolves, but on a timescale that makes the changes feel gentle rather than abrupt. Standing inside a cave, it becomes easier to understand Earth not as a place that constantly acts, but as one that allows water to move, allows rock to dissolve, allows time to accumulate without interference. The darkness is not emptiness, but a kind of quiet agreement between physics and patience. Each drip is small, almost insignificant on its own, yet together they build chambers large enough to hold forests, rivers, and echoes of ancient voices. This is the same principle that guides rivers across landscapes and continents across the globe. Change emerging from countless minor actions rather than dramatic moments. As caves continue to form and grow, Unseen by most, they extend the planet's memory inward, creating spaces where time slows, sound softens, and motion becomes almost imperceptible, adding another layer to Earth's long, ongoing story beneath the surface, where movement continues quietly, one drop following another, without ever needing to hurry. With every exhale, the ocean answers in its own way, not immediately and not loudly, but through processes so vast and steady that they feel almost like background existence rather than action. After following water through rivers and down into caves, it eventually returns to the sea, and there it becomes part of the largest continuous system on the planet, one that regulates climate, stores memory, and quietly supports nearly all life on Earth. The ocean is not just a container for water. It is an engine, a buffer, and a living surface where chemistry, physics, and biology meet without pause. Most of the oxygen in the air did not come from forests or fields, but from microscopic organisms drifting near the ocean's surface. Phytoplankton, too small to see without magnification, float in the sunlit upper layers of seawater, performing photosynthesis just as plants do on land. They take in carbon dioxide and release oxygen, building their tiny bodies from light and dissolved nutrients. Collectively, they produce more than half of the oxygen humans breathe, even though they live far from shore and far from awareness. These organisms bloom and fade with the seasons, responding to currents, temperature, and light. When conditions are right, they multiply rapidly, turning large areas of the ocean faintly green or blue when seen from space. When conditions change, they decline just as quietly, sinking into deeper waters where they become food for other organisms or dissolve back into the system. The oxygen they release does not rush upward. It mixes slowly into the atmosphere, blending with air from forests, grasslands, and cities, becoming part of the shared envelope that surrounds the planet. The ocean also absorbs heat, more heat than the land or atmosphere combined. Sunlight penetrates the surface and warms the upper layers, and currents move that warmth across the globe. Warm water flows toward colder regions, releasing heat into the air, while cold water sinks and travels back toward the equator. This circulation smooths out temperature extremes, preventing Earth from becoming too hot in some places and too cold in others. Without this constant redistribution, climates would be harsher and less stable, and life would be confined to far narrower bands. The ocean performs this work without effort or intention, guided only by density, salinity, and gravity. Salt plays a quiet role in this process. As seawater freezes in polar regions, salt is left behind, increasing the density of the surrounding water and causing it to sink. This sinking water drives deep currents that travel vast distances along the ocean floor, rising again elsewhere after centuries or even millennia. A molecule of water that sinks near Antarctica may not surface again until it reaches the North Atlantic, carrying with it dissolved gases and nutrients gathered along the way. In this sense, the ocean breathes on a timescale far longer than any human life, inhaling heat and carbon, exhaling cold and oxygen, cycling endlessly without exhaustion. Carbon dioxide dissolves readily in seawater, and the ocean absorbs a significant portion of what enters the atmosphere. Some of this carbon is taken up by phytoplankton and passed through the food web, eventually sinking to the seafloor as organic matter. Some reacts with minerals to form carbonate compounds, becoming part of shells, skeletons, and eventually limestone. Over geological time, this process locks carbon away in rock, regulating the planet's temperature by controlling how much remains in the air. The ocean does not solve problems. It participates in balances. When inputs increase, responses follow, sometimes slowly, sometimes unevenly, but always according to the same physical rules. Even the surface of the ocean is rarely still. Waves move energy across vast distances, generated by winds that themselves were shaped by temperature differences between land and sea. Tides lift and lower the water, twice daily in response to the gravitational pull of the moon and sun, exposing and submerging coastlines in a steady rhythm. Along these shifting margins, life adapts to constant change, developing ways to cling, burrow, or retreat as water comes and goes. The sound of waves breaking on shore is the audible expression of energy dissipating, of motion finding rest for a moment before continuing elsewhere. Beneath the surface, sound travels farther and faster than it does in air, carrying the calls of whales across entire ocean basins. These low-frequency sounds move through layers of water with different temperatures and densities, bending and reflecting in ways that allow communication over astonishing distances. The ocean is never silent, even when it appears calm from above. It hums with movement, vibration, and life, most of it unnoticed. The sea also holds memory in subtler ways. Sediments settle on the ocean floor year after year, forming layers that record changes in climate, biology, and chemistry. Tiny shells of plankton accumulate, preserving information about ocean temperature and composition at the time they lived. Volcanic ash from distant eruptions falls through the water and becomes part of the sediment record. Even shifts in Earth's orbit leave traces in the arrangement of layers, revealing cycles of ice ages and warm periods stretching back millions of years. The deep sea is both archive and engine, storing the past while driving present conditions. Life in the ocean reflects this continuity. Many marine organisms move slowly, conserving energy in an environment where food can be sparse and distances vast. Jellyfish drift with currents rather than fighting them. Corals build reefs millimetre by millimetre, growing structures large enough to be seen from space through the collective effort of countless small animals. Fish follow currents that have existed for generations, migrating along routes shaped by temperature and productivity rather than landmarks. Even predators rely on patterns established long before they were born. For humans, the ocean often feels separate, something to visit rather than inhabit. Yet its influence reaches everywhere. The rain that feeds rivers began as evaporated seawater. The oxygen in the air owes much to marine life. The climate patterns that shape weather are driven largely by ocean currents. Even the minerals in our bodies were once dissolved in ancient seas. The boundary between land and ocean is not a line but a gradient, a place of exchange rather than separation. When you breathe, that exchange continues. Air moves into lungs and out again, carrying oxygen that may have come from a bloom of phytoplankton thousands of kilometers away. Carbon dioxide leaves the body and eventually finds its way back into water or leaf or stone. The ocean does not know this individually, but collectively it responds, absorbing, releasing, circulating. Its vastness allows it to act as a stabilizer, taking in fluctuations and redistributing them slowly enough that life can persist. This is why the ocean feels calming to so many people, even when they don't consciously understand its role. There is something reassuring about a system so large that individual disturbances fade into broader patterns. Waves rise and fall, currents shift, seasons pass. Through it all, the ocean continues its work, breathing on a planetary scale, answering each exhale not with sound or motion you can feel, but with balance maintained quietly, steadily, and without pause. Some nights the shoreline becomes a quiet galaxy, and the boundary between sea and sky seems to dissolve into points of light that respond to the smallest movement. After learning how the ocean breathes and circulates energy and life, it feels almost natural that it can also glow, not with reflected moonlight, but with light produced by life itself. In certain bays and lagoons around the world, when darkness settles fully and the water grows calm, a single step into the shallows can awaken a faint blue shimmer, as if stars have slipped from the sky and decided to linger in the tide. Each ripple, each slow wave, draws brief trails of light that appear and vanish again, leaving the water dark once more. This glow is not decoration and not magic, though it often feels like both. It is the work of countless microscopic organisms called dinoflagellates, drifting near the surface, carrying within their tiny bodies the ability to produce light through chemistry alone. These organisms are part of the same phytoplankton communities that help supply oxygen to the atmosphere, but under the right conditions they reveal another side of their existence. When disturbed by motion, a breaking wave, a paddle slicing through water, even the movement of fish beneath the surface, they emit a brief flash of blue-green light. The chemistry behind this glow is precise and efficient. Inside a cell, a molecule called luciferin reacts with oxygen, guided by an enzyme known as luciferase, releasing energy as visible light. The reaction produces very little heat, making it what scientists call cold light, nearly all energy converted directly into illumination. This process evolved independently many times across the tree of life, but in dinoflagellates it serves a particular purpose. The sudden flash can startle or confuse predators, or draw the attention of larger animals that may feed on whatever caused the disturbance. It is not a signal meant for beauty, yet beauty emerges as a byproduct. Entire bays can glow when conditions are right, usually where water is warm, nutrients are plentiful, and circulation allows these organisms to accumulate rather than disperse. Places like Mosquito Bay in Puerto Rico or quiet coves in tropical regions become theatres for this phenomenon, where even gentle rain can set the surface alight with countless pinpricks of blue. The experience of seeing bioluminescent water often leaves a lasting impression because it feels intimate. The light responds directly to movement, appearing where you touch the water and fading where you don't. It creates the sense that the ocean is aware, answering motion with light, though of course it is only following chemistry and physics. Still, that responsiveness ties into the larger patterns of the sea, how life and environment interact constantly, how energy flows through systems in ways that can be subtle or spectacular depending on the moment. Dinoflagellates spend most of their lives unnoticed, drifting with currents, photosynthesizing by day, dividing and sinking and rising in daily cycles. Some species migrate vertically, moving closer to the surface at night and sinking during daylight, balancing light exposure with nutrient access. This movement influences when and where the glow appears. Calm nights after sunny days often produce the strongest displays when populations are dense and near the surface. Storms or strong winds can scatter them, dimming the effect until conditions settle again. In this way, the glow is a reflection of balance, not just within the organism, but within the surrounding system. The ocean's breathing, its circulation of nutrients and heat, sets the stage for moments like these. Without stable currents and predictable cycles, the glow would not gather. Bioluminescence is not limited to shallow waters. In the deep ocean, where sunlight never reaches, light produced by living organisms becomes one of the dominant features of the environment. There, creatures use bioluminescence for communication, camouflage, hunting, and defense. Some produce steady glows, others flash patterns, and some release clouds of light like underwater smoke screens. The chemistry is similar, but the purposes vary widely. In the deep sea, light replaces colour and shape as a primary means of interaction. Yet even this hidden world connects back to the surface. Nutrients sinking from above support deep ecosystems. Currents carry organisms and genetic material between layers. The same principles govern both realms, even if their expressions differ. Along shorelines, bioluminescent events often feel fleeting. A wave breaks, glows briefly and fades. Footprints on wet sand light up for a moment and then vanish. The experience mirrors many of Earth's processes, visible only under certain conditions, requiring patience and timing. It cannot be forced or prolonged. It arrives when systems align and disappears when they don't. This impermanence adds to its calming effect. There is nothing to capture or hold on to, only something to witness while it lasts. Even the light itself is temporary, existing for fractions of a second before darkness returns. Yet across an entire bay, those brief flashes combine into something expansive, a reminder that countless small actions can create a wide-reaching effect. The glow also hints at the continuity of life in the ocean. Dinoflagellates have existed for millions of years, surviving changes in climate, chemistry, and geography. Some species are photosynthetic, others predatory, some both. They form the base of many marine food webs and occasionally contribute to harmful algal blooms when conditions push systems out of balance. Even then, they are not acting with malice or intent, simply responding to available resources. The same organisms that create quiet wonder at night can also remind us of the ocean's sensitivity to change, but in calm conditions their glow feels like a gift, a visual whisper of the chemistry that underpins so much of life on Earth. Watching bioluminescent water can feel like standing at the edge of two worlds, the familiar surface and a hidden realm revealed only briefly. It ties together themes already woven through this story: persistence without urgency, beauty emerging from simple rules, vast systems expressing themselves through small, repeatable actions. The shoreline becomes a place where breathing oceans, drifting rivers, dissolving rock and moving continents all converge, expressed not through force, but through light that flickers and fades as gently as it appears. And as the waves continue their steady rhythm, the glow answers again and again, not every night, not everywhere, but often enough to remind anyone who sees it that the planet is alive with processes that can still surprise, even when they operate quietly, just beneath the surface, waiting for darkness and a moment of motion to briefly make themselves known. A world that never sees the sun yet keeps living begins just below the reach of light, where the ocean slowly changes character without any clear boundary to announce the shift. After the surface glow fades and colours dissolve into blue, there comes a depth where daylight weakens enough that shadows disappear and shapes soften, a region often called the twilight zone, not because it is dark, but because it exists between knowing and unknowing. Here, light still arrives, but only as a suggestion, scattered and thinned until it can no longer support photosynthesis. The ocean above is busy with wind and waves and shifting brightness, but below, movement becomes more deliberate, and time seems to stretch. Creatures in this zone are neither surface dwellers nor deep-sea specialists, but something in between, adapted to low light, cooler temperatures, and a rhythm governed by vertical migration rather than day and night as we experience it. Many animals here rise toward the surface at night to feed and sink again before dawn, tracing daily journeys that span hundreds of meters, the largest mass migration on Earth, happening every evening without sound or spectacle. These movements transport nutrients upward and carbon downward, connecting layers of the ocean in a slow, breathing exchange that mirrors the larger cycles already unfolding above. As depth increases, pressure builds in a way that is difficult to imagine from the surface. Every 10 meters adds another atmosphere of pressure, stacking weight upon weight until the water presses with a force strong enough to crush unprotected airspaces. Yet life continues, not by resisting this pressure, but by yielding to it. Deep-sea organisms have no empty cavities that could collapse. Their tissues are flexible, their chemistry tuned to function under compression. Proteins are structured differently, membranes behave differently, and even the rules of metabolism shift slightly to accommodate an environment that never relaxes its grip. This is not a hostile adaptation, but a calm one, shaped gradually over countless generations. Fish with translucent bodies drift without effort. Jelly-like creatures pulse slowly, conserving energy in the cold. Others extend long, delicate appendages to sense the faintest vibrations, navigating a world where vision is limited and touch becomes primary. Bioluminescence, encountered at the surface as a fleeting glow, becomes a common language here, used not for beauty but for survival, signaling, distraction, or camouflage. Light produced by these animals is often tuned to specific wavelengths that travel farthest in water, blue and green dominating, flickering softly in the dark like thoughts passing through a sleeping mind. Deeper still, the twilight gives way to true night, a place of complete darkness where the sun has never reached and never will. This is the realm of the deep sea, covering most of the planet's surface yet remaining largely unexplored. Vast plains stretch across the ocean floor, broken by ridges, canyons, and trenches that plunge deeper than any mountain rises above sea level. The Mariana Trench, the deepest known point, descends nearly 11 kilometers below the surface, a distance so great that if Mount Everest were placed there, its peak would still lie underwater. At such depths, pressure becomes almost abstract, yet even here, life persists. Tiny crustaceans scuttle across sediment. Worms burrow slowly through mud that has settled grain by grain for millions of years. Fish hover in place, their movements minimal, conserving energy in a world where food arrives unpredictably, often as a slow rain of organic matter drifting down from above. This material, known as marine snow, is made of dead plankton, waste, and fragments of life, descending constantly, feeding ecosystems that never see the sun. In some places, the deep sea is punctuated by hydrothermal vents, cracks in the ocean floor where mineral-rich water heated by Earth's interior gushes into the surrounding cold. Around these vents, entire communities thrive without sunlight, relying instead on chemosynthesis, bacteria that convert chemicals like hydrogen sulfide into energy. Larger organisms form symbiotic relationships with these microbes, hosting them within their bodies and sharing the energy they produce. Tube worms, clams, and shrimp cluster around vents, their forms alien but their existence grounded in the same principles of exchange and balance seen elsewhere on the planet. These ecosystems demonstrate that life does not require light, only gradients and time, a reminder that Earth's creativity extends into places we rarely imagine. The deep sea also holds vast silence, but like the silence of caves, it is not empty. Sound travels efficiently through water, and the ocean carries low-frequency noises across immense distances. Earthquakes, storms, and the calls of whales ripple through the depths, registering on sensitive bodies attuned to vibration. Even the planet itself contributes to this soundscape as tectonic plates shift and sediments settle, producing subtle noises that blend into a constant low hum. For creatures living here, this acoustic environment replaces the visual one, shaping how they perceive space and presence. Humans have visited this realm only briefly and rarely, descending in submersibles or lowering instruments that glimpse fragments of a world too large to comprehend all at once. Each expedition reveals new species, new behaviors, and new questions, emphasizing how little of the deep ocean has been mapped or studied. Yet this lack of knowledge does not make the deep sea frightening so much as humbling. It exists without reference to us, functioning according to rules that have held steady for millions of years. Its creatures are not monstrous, but efficient, shaped by scarcity and stability rather than aggression. Many move slowly, conserving energy. Some appear fragile but are perfectly suited to their environment. Their gentleness comes from necessity, not weakness. The deep sea also plays a role in Earth's long memory. Sediments accumulating on the ocean floor preserve records of climate change, volcanic activity, and biological shifts stretching back tens of millions of years. In these layers, scientists read stories of ice ages advancing and retreating, of oceans warming and cooling, of life diversifying and reorganizing itself. The deep ocean is both archive and participant, storing information while continuing to influence surface conditions through circulation and chemistry. Thinking of the deep sea as Earth's dreaming mind is not to suggest consciousness, but to recognize its role as a place where processes unfold slowly, largely unseen, shaping outcomes that emerge elsewhere. Like dreams, these processes operate below awareness, drawing from deep patterns and histories, occasionally surfacing in ways that surprise or illuminate. Currents born in the deep influence weather far above. Nutrients stirred from the seafloor feed surface blooms. Carbon locked away in sediments helps regulate temperature over geological time. All of this happens without attention, guided by the same patient principles seen in rivers, caves, and drifting continents. The deep sea does not rush to reveal itself. It waits, continuing its quiet work, supporting life in forms both familiar and strange, reminding anyone who pauses to consider it that even in complete darkness, the planet remains active, creative, and alive, carrying its slow, steady thoughts forward through time, far below the surface, where the sun has never shone but life has never stopped. Ice looks frozen, but it travels, and it carries with it a memory far older than any living thing. After drifting through oceans and sinking into the deep, after glowing briefly at the shoreline and moving through darkness below, water eventually finds another form, one that appears still but is never truly at rest. In cold regions where snow falls faster than it melts, layers begin to build, season after season, pressing gently on what came before. The weight is slow and constant, compressing loose snow into firn and then into solid ice, squeezing out air until what remains is locked away in tiny bubbles, each one a sealed sample of the atmosphere as it once was. Over time, this accumulating mass begins to move, not suddenly, not dramatically, but with the same patience seen in rivers and continents. A glacier is not a static block. It flows, inching forward under its own weight, bending and deforming internally, responding to gravity and terrain like an extremely slow river made of crystal. From a distance, glaciers appear rigid and immovable, but up close their motion becomes evident in creaks, fractures, and subtle shifts. Crevasses open where ice stretches over uneven ground, revealing deep blue interiors where light penetrates and scatters, a colour born from thickness rather than pigment. These cracks are not signs of failure, but expressions of movement, reminders that even the hardest ice yields when pressure is applied long enough. As glaciers advance, they reshape the land beneath them. Rock is plucked from valley walls and ground against the bedrock, carried along embedded in the ice like tools in a moving workshop. Over thousands of years, this abrasion smooths mountains, deepens valleys, and leaves behind polished stone marked with long, parallel scratches that point in the direction of travel. U-shaped valleys, broad and flat-bottomed, stand as signatures of glacial passage, different from the V-shaped valleys carved by rivers. When glaciers retreat, they leave behind moraines, ridges of debris that trace former edges, quiet outlines of where ice once rested. Lakes often fill the depressions left behind, occupying spaces excavated by ice that moved on long ago. These landscapes feel calm and open, shaped not by sudden force, but by prolonged contact. Ice also moves vertically, not just across land. In massive ice sheets like those covering Greenland and Antarctica, layers near the surface are relatively young, while those deeper down may be hundreds of thousands of years old. Drilling into these sheets reveals a vertical timeline, each meter descending into a different chapter of Earth's past. Scientists extract ice cores, long cylinders pulled carefully from the depths, preserving layers intact. Within them, trapped air bubbles contain samples of ancient atmospheres, allowing direct measurement of past concentrations of gases like carbon dioxide and methane. Tiny particles of dust and ash record volcanic eruptions and wind patterns. Variations in isotopes reveal temperature changes over time. These cores do not speak loudly, but they speak clearly, telling stories of ice ages advancing and retreating, of climates shifting gradually or abruptly, of systems responding to small changes amplified over long periods. The ice remembers what the surface forgets. Unlike rock layers that can be folded, eroded, or overwritten, ice preserves its record in a continuous sequence as long as it remains frozen. Each snowfall becomes a page, each compression a binding. Even the movement of glaciers does not erase this record entirely. Layers deform but remain identifiable, stretched and tilted yet still readable. In this way, ice serves as both traveller and archivist, moving across the land while carrying a vertical memory within itself. The pace of this movement is deceptive. A glacier may advance only a few centimetres or metres per day, slow enough that its progress feels imperceptible. Yet over centuries this adds up to kilometres of travel. Villages, forests, and entire ecosystems have been overridden by ice in the past, not suddenly, but steadily, giving life time to retreat or adapt. This gradual advance and retreat has shaped not only landscapes, but evolutionary pathways, isolating populations, opening corridors, and resetting environments. Even now in high mountains and polar regions, glaciers continue their quiet journeys, responding to shifts in temperature and snowfall, adjusting their balance between accumulation and melting. The sounds associated with ice are often subtle, a distant crack, a low groan, the occasional thunderous carving where ice meets water and breaks away into floating fragments. These sounds are reminders that ice is under constant stress, always negotiating between solidity and flow. At the edges, meltwater streams emerge, carrying fine sediment known as glacial flour that turns rivers milky and feeds distant ecosystems with minerals ground from ancient rock. This water, once locked away, rejoins the broader cycle, flowing toward the sea, where it influences salinity, circulation, and life. In polar oceans, melting ice freshens surface waters, affecting how they mix and sink, subtly altering currents that travel far beyond the ice's reach. Ice does not exist in isolation. It participates fully in the planet's interconnected systems. Even frozen, it exchanges energy with the air above and the land below, reflecting sunlight back into space with its bright surface, helping regulate temperature. This reflectivity, known as albedo, is one reason ice-covered regions remain cool. When ice retreats, darker land or water absorbs more heat, reinforcing change. These feedbacks are not sudden switches but gradual responses unfolding over time. The memory ice holds is not just of the past, but of patterns, of how the planet responds to shifts in balance. For humans, ice often feels distant, something encountered on mountaintops or in faraway, polar regions. Yet its influence reaches far beyond those places. Sea levels respond to the growth and melting of ice sheets. Weather patterns are shaped by temperature contrasts maintained in part by ice cover. Even the air we breathe carries signatures of processes recorded in ice cores, linking present conditions to ancient ones. To stand near a glacier is to stand near time made tangible. The ice creaks and flows, indifferent to observation, continuing a journey that began long before any witness arrived. It does not hurry, and it does not stop. It advances when conditions allow and retreats when they don't, leaving behind landscapes that feel open and quiet, as if designed for contemplation. Like caves and deep oceans, glaciers offer a sense of slowed time, a reminder that not all motion needs speed to be powerful. Their memory is not stored in stories or monuments, but in layers, pressure, and movement, carried forward silently as ice travels grain by grain across the surface of the earth. A desert is not dead, it's just waiting, holding its energy close in a place where time stretches and movement becomes subtle. After ice that remembers and oceans that breathe, the land shifts again into a form that looks still from a distance, pale and quiet, shaped by the absence of water more than its presence. Deserts are often imagined as empty, but emptiness is only a surface impression. Beneath the heat of the day and the cool of the night, deserts are full of slow strategies, long pauses, and brief moments of intensity that ripple outward and then settle back into stillness. Sand dunes move like waves frozen mid-motion, yet they are always in transit, pushed grain by the wind. Each gust lifts particles just high enough to hop forward, landing softly on the slope below, gradually shifting entire hills of sand across the landscape. A dune that seems unchanged over years may have travelled dozens of meters, its shape maintained even as its substance constantly changes. Like rivers, dunes follow rules of efficiency, arranging themselves according to wind direction, speed and supply. Crescent-shaped Martian dunes form where sand is scarce, long linear dunes align with steady winds, and star dunes rise where winds shift direction over time. These patterns are not random. They are signatures of airflow written slowly into the land. Desert air carries sound differently too. At night, when temperatures drop and the atmosphere becomes more stable, distant noises travel farther. A single footstep can echo softly, and the wind itself sometimes produces low humming tones as it passes over dunes, caused by grains sliding together in synchrony. These sounds are rare and fleeting, but they add to the sense that the desert is attentive, responding quietly to movement. When the sun sets, the desert transforms. Heat radiates away quickly, and the temperature can drop dramatically, revealing a sky so clear and dark that stars appear almost crowded, with little, moisture in the air to scatter light. The Milky Way stretches overhead in sharp detail, a reminder that deserts on Earth often feel closer to space than to forests or oceans. Life in deserts adapts to these extremes not by fighting them, but by stepping aside. Many animals are nocturnal, emerging only after the heat fades. Reptiles warm themselves quickly in the morning sun and retreat before midday. Mammals conserve water through efficient kidneys and behavior that minimizes exposure. Plants too employ patience. Some store water in thick tissues, others reduce surface area to limit evaporation, and many retreat underground entirely, surviving as seeds for years or even decades. These seeds are tuned to respond to specific cues, temperature changes, moisture levels, chemical signals, ensuring that when they do germinate, conditions are favorable. When rain finally comes, the response can feel miraculous. Dormant seeds sprout almost overnight, carpeting the ground with flowers in bursts of colour that seem impossible given the days before. These blooms are brief, lasting only as long as moisture remains, but they attract insects, birds and mammals, triggering a cascade of activity. Pollination happens quickly, seeds set rapidly. Then, as water evaporates and the soil dries, plants complete their life cycles and fade away, leaving behind the next generation waiting in silence. This rhythm of waiting and sudden abundance defines desert time, not measured in seasons so much as in events. Even soil in deserts tells a story of patience. Biological soil crusts composed of cyanobacteria, fungi, lichens and mosses form thin, dark layers on the surface. They bind loose particles together, reducing erosion and retaining moisture, creating microhabitats for seeds and insects. These crusts grow slowly, sometimes taking decades to establish, but they play an outsized role in stabilizing the landscape. A single footprint can disrupt them, setting back years of growth, another reminder that deserts operate on extended timescales where small disturbances linger. Water, when it does move through deserts, often does so suddenly. Dry channels called wadis or arroyos remain empty most of the year, their beds cracked and dusty, until distant rain sends a surge racing downstream. These flash floods carve channels, redistribute sediment and recharge groundwater, then disappear again, leaving behind a reshaped path. The land remembers these flows long after the water is gone, in smoothed stones and rearranged banks. Over time, these rare events do much of the shaping work, proving that even infrequent movement can have lasting impact when given enough repetition. Deserts also hold records of past climates. Beneath dunes and gravel plains lie ancient lake beds, fossil soils, and remnants of vegetation from wetter periods. The Sahara, now the largest hot desert on Earth, once supported grasslands, rivers, and abundant wildlife, a shift driven by gradual changes in Earth's orbit that altered monsoon patterns. These transitions happened slowly, giving ecosystems time to adapt or migrate, and their traces remain etched into the land. Rock art depicting hippos and crocodiles sits alongside present-day sand, a quiet reminder that landscapes are not fixed identities, but phases in a longer story. Even the heat of deserts plays a role in shaping life gently rather than harshly. Temperature extremes drive chemical reactions in rocks, causing them to expand and contract, slowly breaking apart into smaller fragments. Wind carries these fragments away, sorting them by size and weight, refining sand over time. This process is slow and continuous, another example of how deserts work not through force, but through persistence. At night, as temperatures fall, moisture in the air can condense on cool surfaces, providing small but vital amounts of water to plants and animals. Beetles tilt their bodies to collect droplets. Plants absorb moisture directly through leaves or stems. Life makes use of whatever is available, no matter how slight. To walk through a desert is to move through a place attuned to subtlety. Tracks in the sand reveal nocturnal journeys. A slight change in plant spacing hints at underground water. The sound of wind shifts with terrain. Nothing is wasted and nothing is rushed. The desert waits because waiting works. It allows resources to accumulate, strategies to align, and life to persist in forms that do not demand constant abundance. In this way, deserts echo themes already woven through Earth's story: movement without urgency, change through repetition, resilience built on patience. They are not empty spaces between more active regions, but systems operating on a different rhythm, one that rewards stillness and attentiveness. As night settles and the desert cools, stars wheel overhead and dunes continue their slow migrations, grains sliding quietly forward, seeds resting below, animals emerging, briefly and then retreating again, all part of a landscape that is alive not through constant motion, but through the ability to wait until the moment is right. A forest doesn't just live under weather, it helps create it, shaping the air above with countless small actions repeated leaf by leaf, tree by tree. After deserts that wait and ice that travels, the landscape gathers itself into something denser, layered, and quietly active. Forests are often described as places of shade and shelter, but their influence reaches far beyond the ground they occupy. Every tree is a vertical river, drawing water up from the soil through roots and vessels, lifting it meter by meter until it reaches the leaves. There, under sunlight, a portion of that water is released back into the air through tiny openings called stomata, a process known as transpiration. It happens continuously during daylight hours, invisible but persistent, turning liquid water into vapor that drifts upward and outward. A single large tree can release hundreds of liters of water into the atmosphere in a single day, and when millions of trees do this together, the effect becomes regional. The forest exhales moisture, and that moisture changes the sky. As warm, humid air rises from the canopy, it cools, condenses, and forms clouds. In this way, forests recycle rain, returning water to the atmosphere so it can fall again, often not far from where it first landed. In large forest systems like the Amazon, this recycling happens multiple times as air masses move inland, each cycle carrying moisture deeper into the continent. Rain does not simply arrive from the ocean and disappear. It is caught, lifted, shared, and released again, a loop sustained by leaves and light. Walking beneath a dense canopy, especially after rain, this process becomes almost tangible. The air feels heavier, cooler, scented with soil and resin. Mist hangs between trunks as sunlight filters through, breaking into soft beams that reveal moisture drifting upward. This is not fog drifting in from elsewhere, but breath rising from the forest itself. Each leaf contributes a fraction, and together they create an atmosphere that feels alive, responsive, and calm. The forest floor absorbs rain slowly, protected by layers of litter and roots that reduce runoff and erosion. Water seeps downward, replenishing groundwater and streams, extending the influence of a single storm over days or weeks. This moderation smooths extremes, reducing floods and sustaining flow during dry periods. Trees do not act alone in this. Fungi connect roots underground in vast networks, redistributing water and nutrients between plants. A tree growing in shade may receive resources from one in sunlight. A stressed plant may be supported temporarily by its neighbours. These exchanges influence how much water is taken up and released, subtly shaping transpiration patterns across the forest. The result is not uniform breathing, but a textured rhythm that responds to light, temperature, and moisture. Forests also affect temperature directly. Leaves absorb sunlight, but they also use much of that energy to evaporate water rather than heating the air. This evaporative cooling keeps forested regions cooler than surrounding open land, reducing temperature extremes. At night, the canopy traps heat, slowing cooling and creating a more stable environment for organisms below. These effects influence wind patterns, drawing air toward forested areas during the day and altering local circulation. Over large regions, these small adjustments accumulate, guiding weather systems in ways that are only beginning to be fully understood. The idea that forests make weather is not metaphorical. It is physical, measurable, and ongoing. Cloud formation, rainfall distribution, and even storm paths can be influenced by the presence or absence of trees. When forests are removed, these patterns change. Air becomes drier, rainfall may decrease or shift, temperatures swing more widely. The land responds not with immediate collapse, but with gradual adjustment, often becoming more vulnerable to drought and erosion. Yet where forests remain intact, their influence persists quietly, maintaining cycles that support not only trees, but rivers, soils, and distant ecosystems. Life within forests adapts to this self-created climate. Plants with broad leaves capture light efficiently in humid air. Epiphytes grow on branches, drawing moisture directly from mist. Animals time their movements to daily cycles of temperature and humidity. Insects emerge when conditions are right for flight. Birds synchronize breeding with rainfall patterns sustained by the canopy above them. Even microorganisms respond, thriving in stable, moist environments where organic matter decomposes slowly, releasing nutrients back into the soil. Everything participates in the forest's breath, from the tallest emergent trees to the smallest fungal threads. Forests also store carbon, pulling it from the air and locking it into wood, leaves, and soil. This storage is not permanent, but it is long-lived, slowing the movement of carbon through the atmosphere and moderating climate over decades and centuries. When trees grow, they take in carbon dioxide. When they die and decay, some of that carbon returns to the air, but much becomes part of the soil, held there by complex interactions between roots, microbes, and minerals. This balance is dynamic, not static, shifting with growth, disturbance, and recovery. Forests experience cycles of change just like deserts and ice, shaped by fire, storms, and regeneration. Fire clears old growth, releasing nutrients and opening space for new plants. Storms topple trees, creating gaps that let sunlight reach the forest floor. These disturbances are not failures, but part of the system's way of renewing itself. Afterward, growth resumes, often faster and more diverse than before. The breath continues, sometimes altered in rhythm, but rarely silenced. To sit quietly in a forest is to become aware of this exchange. Leaves rustle as air moves through, moisture rises invisibly. The temperature feels moderated, neither harsh nor extreme. There is a sense of enclosure that is not confining, a feeling that the space is being actively maintained rather than passively occupied. This calm is not accidental. It is the result of countless interactions layered over time, a system that has learned, through evolution, how to regulate itself using light, water, and structure. Forests do not impose control over weather. They participate in it, shaping outcomes through cooperation rather than force. In doing so, they echo the broader themes of Earth's story: change through persistence, balance through repetition, life-shaping environment and being shaped in return. As mist lifts from the canopy and clouds gather above, the forest continues its quiet work, breathing water back into the sky, sustaining cycles that extend far beyond the trees themselves, linking soil to cloud, leaf to rain, and ground to air in a steady exchange that feels as natural and reassuring as breathing itself. The most important wilderness might be the one you never see, stretched thin beneath your shoes, quietly active in ways that rarely draw attention. After forests that breathe and deserts that wait, the story moves downward into a space so familiar it often disappears from awareness. Soil looks like matter at rest, a mixture of dirt and fragments, but it is one of the most dynamic places on the planet. Every handful contains a living community, crowded and busy, operating on scales both microscopic and immense. Bacteria, fungi, protozoa, nematodes, insects and worms share this space, each performing roles shaped by millions of years of adaptation. They do not compete endlessly. They cooperate, recycle, and transform, turning what falls from above into the foundation for what grows next. Leaves that drift down from the canopy do not vanish when they touch the ground. They enter a process that begins slowly, as moisture softens their structure and fungi extend thread-like hyphus into their tissues. These fungal networks secrete enzymes that break complex molecules into simpler forms, releasing nutrients locked inside. Bacteria follow, specializing in different chemical tasks, some decomposing cellulose, others breaking down lignin, others converting nitrogen into forms plants can use. This work produces heat, faint but constant, making soil slightly warmer than the air above on cool nights. It also produces carbon dioxide, water, and a steady supply of minerals that feed roots and microbes alike. Nothing is rushed. Decomposition proceeds at a pace set by temperature, moisture, and community balance, slowing in cold or dry conditions, accelerating when warmth and water return. Worms move through this environment like quiet engineers. As they burrow, they mix layers of soil, pulling organic matter downward and bringing mineral-rich particles up. Their tunnels create pathways for air and water, improving drainage and oxygen availability. The material they excrete, known as castings, is finely textured and rich in nutrients, supporting plant growth more effectively than many fertilizers. Charles Darwin once observed that the surface of the land passes again and again through the bodies of worms, a statement that sounds poetic but is simply factual over long periods. Even a seemingly undisturbed meadow is being constantly reworked from below. Fungi extend this influence further through mycorrhizal networks that connect plant roots over large distances. These networks act as conduits for water, nutrients, and chemical signals. A tree under stress from drought or pests may send signals through fungal threads, prompting nearby plants to adjust their chemistry or share resources. Seedlings can receive carbon from older plants, helping them establish in shade. These exchanges are not altruistic. The fungi benefit as well, receiving sugars produced by photosynthesis. The relationship persists because it works, not because it is kind. Through these networks, soil becomes a communication medium, a place where information flows alongside matter. Soil structure itself emerges from these interactions. Particles of sand, silt, and clay bind together into aggregates held by organic compounds produced by microbes and roots. These aggregates create pores of different sizes, allowing water to infiltrate slowly rather than running off. and air to circulate without drying everything out. Healthy soil feels crumbly, neither compacted nor loose, reflecting a balance achieved through countless small actions. This structure protects organic matter from rapid decomposition, allowing carbon to be stored for years or decades, further stabilizing the system. In this way, soil moderates extremes, holding on to moisture during dry periods and releasing it gradually, buffering plants against sudden changes. Beneath grasslands, forests, and even deserts, soil communities adjust to local conditions. In dry regions, microbes enter dormant states, reactivating quickly when rain arrives. In cold environments, decomposition slows, allowing organic matter to accumulate. In wetlands, low oxygen conditions favor different microbial processes, producing methane and preserving plant material as peat. Each soil tells a story about climate, vegetation, and time, written not in layers like rock or ice, but in texture, chemistry, and living composition. Soil also acts as a filter. As water moves downward, microbes and mineral surfaces capture pollutants, pathogens, and excess nutrients, cleaning the water before it reaches groundwater or streams. This service happens continuously, without intention or awareness, yet it supports entire ecosystems downstream. When soils are disrupted or removed, this filtering capacity diminishes, and the effects ripple outward, altering water quality far beyond the point of disturbance. Yet where soil remains intact, it quietly maintains balance, absorbing shocks and smoothing transitions. Even the smell of soil after rain, often called petrichor, reflects its living nature. That scent comes from compounds released by bacteria and plants, lifted into the air when dry soil is moistened. It signals microbial activity resuming, spores dispersing, chemistry restarting. The smell is not decorative. It is a message that the system is awake again, responding to a shift in conditions. Many animals, including humans, respond to it instinctively, perhaps because it has long signaled the return of water and growth. Soil is also where past and present intersect. Ancient pollen grains preserved in sediments reveal vegetation histories. Charcoal fragments record fires long extinguished. Bones, seeds, and tools buried and forgotten become part of the matrix, slowly altered but not erased. Archaeologists read soil layers much as geologists read rock, interpreting subtle changes to reconstruct human and ecological stories. The ground beneath cities holds memories of what came before, even if the surface has changed completely. This continuity reinforces the idea that soil is not merely a surface, but a process, always forming, always transforming. The scale of life within soil is staggering. A single teaspoon may contain billions of bacteria, kilometers of fungal hyphae, and a diversity of organisms rivaling that of tropical forests above. Most of these species have never been identified, and many never will be, yet they continue their work regardless. Their interactions determine how ecosystems respond to stress, how quickly landscapes recover from disturbance, and how resilient life remains under changing conditions. When soil health declines, through erosion, compaction, or loss of organic matter, the effects are felt everywhere, from reduced plant growth to altered climate feedbacks. When soil thrives, systems above it gain stability and flexibility. To pause and consider soil is to recognize how much of Earth's activity happens out of sight. While weather moves, overhead and landscapes shift visibly, a quieter universe hums below, recycling matter with patience and precision. Nothing that falls to the ground is truly lost. It is broken down, rearranged, and offered again, supporting new growth in forms that may look different but remain connected. This is not efficiency in a mechanical sense, but continuity in a biological one. Soil does not hurry. It does not waste. It simply keeps working, turning endings into beginnings, sustaining forests, fields, and even the air above, all while remaining mostly unnoticed, a living foundation carrying the planet forward from beneath your feet. For a moment the sky draws with electricity, and then lets the drawing vanish, leaving only memory and a faint echo behind. After soil recycling quietly beneath our feet and forests breathing moisture into the air, energy gathers above, invisible until conditions align. Lightning is not a bolt thrown from clouds, but a release, a balancing act between regions of different electrical charge that have been separating patiently inside a storm. As warm air rises and cool air sinks, water droplets and ice crystals collide and shuffle charge between them. Over time, the top of a cloud becomes positively charged and the bottom negatively charged, while the ground below responds in kind, building its own opposite charge. Nothing looks different from the outside. The sky may appear heavy or calm or quietly expectant, but within the cloud a gradient is forming, pressure building not as heat or wind but as potential. When the difference grows large enough, the air between can no longer resist, and a path opens. Lightning traces that path not all at once but in steps, a faint leader descending invisibly toward the ground, branching and feeling its way through the air. From below, streamers rise to meet it, and when they connect, the circuit completes. In that instant, energy surges, heating the air to temperatures hotter than the surface of the sun, causing it to expand explosively. The brilliant flash we see is not the lightning itself, but the air glowing as it is heated, a brief sculpture made of light and plasma that exists for fractions of a second before collapsing back into darkness. Thunder follows not as a separate event, but as the sound of that expansion, pressure waves travelling outward from the lightning's path. Because sound moves more slowly than light, thunder arrives later, its timing revealing distance rather than intensity. A sharp crack suggests a nearby strike, while a long, rolling rumble indicates lightning farther away, the sound bouncing and stretching as it reflects off clouds, terrain, and layers of air with different temperatures. This delay creates space between sight and sound, a pause that gives lightning its contemplative quality, as if the sky speaks only after considering what it has done. Lightning does not choose targets in a deliberate sense. It follows the easiest path, guided by conductivity and proximity, favouring tall objects, moist ground, and sharp points where electrical fields concentrate. Trees, buildings, and open ground can all become part of the circuit. Most strikes never reach the ground at all, remaining within clouds or leaping between them, invisible to those below. These hidden flashes still release energy, still balance charge, still contribute to the atmosphere's ongoing adjustment. Even when unseen, lightning is working, a reminder that much of Earth's activity happens beyond direct perception. Sometimes lightning leaves behind a physical trace, a rare artifact called a fulgurite. When lightning strikes sandy soil or quartz-rich ground, the intense heat can melt the material instantly, fusing grains into glass before they have time to collapse. The result is a hollow, branching tube that mirrors the path of the lightning through the ground, frozen in place. Fulgurites are fragile and irregular, often breaking apart easily, but they preserve the shape of a moment that would otherwise be lost. Holding one is like holding a shadow made solid, a record of energy that moved too quickly to see in detail. Each fulgurite is unique, shaped by local conditions, moisture, mineral composition, and the specific path the lightning took. They are reminders that even the most fleeting events can leave lasting impressions when circumstances allow. Lightning also plays a role in the chemistry of the atmosphere. The intense heat of a strike breaks apart nitrogen and oxygen molecules, allowing them to recombine into nitrogen oxides, which eventually dissolve in rain and reach the soil as nitrates. These compounds are nutrients for plants, making lightning a small but significant contributor to natural fertilization. Long before industrial processes fixed nitrogen at large scales, storms provided a steady background supply, linking sky to soil through brief flashes of energy. In this way, lightning connects back to the quiet universe beneath our feet, feeding microbial communities and plants that depend on nitrogen to grow. Storms themselves are part of larger circulation patterns, driven by differences in temperature and moisture that forests, oceans, and deserts help shape. Lightning tends to occur where air is unstable, where warm, moist air rises rapidly into cooler layers, creating towering clouds that stretch high into the atmosphere. These clouds are not isolated phenomena, but expressions of energy moving through the system, redistributing heat and moisture. Lightning marks the moments when that redistribution becomes visible, a punctuation in the ongoing flow, rather than a disruption. Even animals respond to lightning in subtle ways. Some species sense changes in electrical fields or pressure before storms arrive, altering behavior in anticipation. Plants exposed to lightning may experience changes in soil chemistry nearby, influencing growth patterns. Forest fires sparked by lightning can reset ecosystems, clearing old growth and opening space for new life, echoing the cycles already seen in forests and deserts. These fires are not acts of destruction alone, but of renewal, part of the same long rhythm of change that shapes landscapes everywhere. Watching lightning from a distance can feel calming rather than frightening when its scale and role are understood. It is energy finding balance, charge redistributing, air responding. The flash is brief, but the processes behind it have been building quietly, and their effects continue long after the light fades. The sky does not hold on to its drawings. It releases them and moves on, leaving behind sound, altered chemistry, sometimes glass in the sand, sometimes only memory. Lightning reminds us that Earth's systems include moments of intensity, as well as long stretches of calm, and that both belong to the same story. After the rumble fades and the air settles, moisture falls as rain, feeding soil, forests, rivers, and oceans once more. The circuit closes not just electrically but narratively, linking sky and ground in a way that feels sudden yet deeply integrated. For a moment the sky draws, and then it lets go, trusting the rest of the planet to carry the energy forward in quieter forms. You're held inside an invisible shield, and sometimes it glows, quietly announcing its presence in the night sky before fading back into something you never have to think about. After lightning sketches briefly across clouds and dissolves into sound, another force continues its work without flashes or noise, surrounding the planet completely, extending far beyond the air we breathe. Earth's magnetic field is not a surface feature or a distant phenomenon. It is a living envelope, generated deep inside the planet and reaching outward into space, shaping how Earth interacts with the Sun and the wider universe. It exists because the planet's core is not still. Beneath the mantle and crust lies a vast ocean of molten iron and nickel, churning slowly as heat escapes from Earth's interior. This movement is driven by convection, the same gentle principle that stirs oceans and air, but here it happens under immense pressure and temperature. As this conductive liquid metal moves and rotates with the planet, it generates electric currents, and those currents create a magnetic field. This process, known as the geodynamo, has been operating for billions of years, switching polarity occasionally, weakening and strengthening, but never fully stopping for long. The result is a field that emerges near the poles and wraps around the planet like a cocoon, deflecting charged particles from the sun and guiding them along invisible lines. Most of the time, this protection goes unnoticed. Solar wind, a constant stream of charged particles flowing outward from the sun, encounters Earth's magnetic field and is diverted, compressed, and guided around the planet rather than striking it directly. Without this shield, Earth's atmosphere would be stripped away gradually, as it was on Mars, leaving the surface exposed to radiation and extreme conditions. Instead, the magnetic field absorbs and redirects much of this energy, allowing life to persist in relative calm. It is not a perfect barrier. Some particles slip through near the poles, where magnetic field lines dip downward, and it is here that the field reveals itself in light. When charged particles enter the upper atmosphere, they collide with atoms of oxygen and nitrogen, transferring energy that is released as photons. The result is the aurora, curtains and arcs of green, pink, and violet light that ripple across polar skies. These displays are not violent. They are gentle interactions, whispers rather than shouts, energy dissipating gracefully after travelling millions of kilometres through space. Auroras shift and pulse slowly, responding to changes in solar activity and magnetic conditions, never repeating the same pattern twice. They are visible reminders that Earth is not isolated, but in constant conversation with the sun, buffered by an invisible structure that translates cosmic energy into quiet beauty. The magnetic field also reaches downward, threading through the crust and into the ground. Beneath your feet, it aligns minerals as rocks form, locking in records of past magnetic orientations. When molten lava cools, iron-bearing minerals settle according to the field at that moment, preserving a snapshot of its direction and strength. Over geological time, these records have revealed that Earth's magnetic poles have reversed many times, flipping north and south at irregular intervals. These reversals do not happen overnight. They unfold over thousands of years, during which the field weakens, becomes complex, and then re-establishes itself in the opposite orientation. Life continues through these transitions, adapting as it always has, buffered by atmosphere and time. The field's presence influences life in quieter ways as well. Many animals have evolved the ability to sense magnetic cues, using them as part of their navigation systems. Birds migrating across continents, sea turtles returning to the beaches where they were born, salmon finding their way back to Natal. Streams, even some insects and bacteria respond to magnetic fields. The mechanisms vary. Some organisms contain tiny crystals of magnetite that align with the field, acting like microscopic compasses. Others rely on chemical reactions sensitive to magnetic orientation, translating direction into visual or neurological signals. These abilities are rarely used alone. They work alongside stars, sun position, smells, and landmarks, forming layered navigation strategies that increase reliability. The magnetic field does not command these journeys. It offers a reference, a steady background pattern that animals learn to read. Even humans respond to the magnetic environment in subtle ways, though not consciously. Our technologies rely on it for orientation and protection. Satellites orbit within its reach. Power grids and communication systems feel its fluctuations during strong solar storms. Engineers account for it when designing infrastructure, acknowledging its presence even if most people never notice. The field's quiet reliability allows complexity to flourish on the surface, just as soil stability supports forests and ocean circulation moderates climate. The magnetic field is another layer of patience, operating continuously without instruction. It is shaped by processes deep below, yet its effects are felt far above. Its strength varies across the globe, stronger near the poles, weaker near the equator, but always present, always adjusting. When solar activity increases, the field flexes and responds, absorbing and redistributing energy. When activity decreases, it relaxes. This responsiveness is not reactive in a nervous sense. It is mechanical, physical, governed by equations rather than intention. Yet it produces outcomes that feel protective. To imagine the planet without this magnetic blanket is to imagine a quieter surface, stripped of atmosphere, water lost to space, life unable to gain a foothold. Instead, Earth remains wrapped, held, allowed to change slowly rather than being eroded quickly. The field does not prevent all change, it shapes the pace of change, giving systems time to respond, adapt, and persist. Like ice that travels slowly, deserts that wait, forests that breathe, and soil that recycles endlessly, the magnetic field is part of Earth's strategy of moderation. It turns extremes into gradients, violence into glow. On nights when auroras appear far from the poles, stretching unexpectedly across dark skies, they feel like messages, though they carry no words. They are simply the field becoming visible for a moment, reminding anyone who looks up that the planet is more than land and water and air. It is also motion, energy, and invisible structure working together. When the lights fade, the shield remains, holding steady, continuing its quiet task of deflecting, guiding, and protecting, an unseen presence that has surrounded every moment of life on Earth, asking for nothing and announcing itself only, occasionally in soft-moving light that drifts across the sky and then disappears. The sea rises and falls like breathing in the dark, guided not by weather or wind, but by a companion that never touches it. After invisible magnetic lines and glowing skies, attention drifts upward to the moon, a presence so familiar it can feel decorative, yet its influence reaches deep into the water and quietly organizes motion across the planet. The moon does not pull the ocean toward itself in a simple way. Instead, it creates a stretching, a subtle distortion of Earth and its waters through gravity. On the side of the planet facing the moon, water is drawn slightly outward. On the opposite side, where Earth itself is pulled more strongly than the water, another bulge forms. Between these two bulges lie regions of lower water level. As Earth rotates, coastlines pass through these zones, experiencing the steady rhythm of rising and falling tides. This cycle happens twice each day, not exactly every 12 hours, but on a slightly longer schedule that reflects the moon's slow orbit around Earth. Each tide arrives about 50 minutes later than the one before, a small delay that accumulates quietly, shifting the timing of high and low water across days and weeks. This rhythm is not hurried. It has been repeating for billions of years, long before any shoreline was named or mapped. The sun participates as well, adding its own gravitational influence. When the sun, moon, and Earth align during full and new moons, their pulls combine, producing spring tides, higher highs and lower lows that expand the tidal range. When the sun and moon sit at right angles during first and third quarters, their influences partially cancel, creating neap tides, gentler shifts that soften the contrast between high and low water. These patterns repeat predictably, forming a slow pulse that coastal ecosystems have learned to read. Tides shape shorelines over time, redistributing sand, carving channels and feeding wetlands. Mudflats emerge and submerge, offering feeding grounds to birds and nurseries to marine life. Estuaries mix fresh and salt water in changing proportions, creating gradients that support diverse communities. Many organisms time their behavior to the tides. Crabs emerge to feed at low water. Fish move with incoming currents. Plants tolerate periodic flooding and drying. Even coral spawning events synchronize with lunar cycles, releasing eggs and sperm into water that carries them efficiently before dispersing. This coordination is not planned. It is learned through survival, reinforced generation after generation by the steady reliability of the lunar rhythm. The moon's influence extends beneath the surface as well. Tidal forces flex Earth's crust slightly, raising and lowering land by centimeters in some regions. This motion can influence volcanic activity and seismic stress over long periods, another example of how gentle forces, applied consistently, can have deep effects. In the ocean, tides drive mixing, moving nutrients from deeper water toward the surface and helping maintain productivity. They interact with currents, winds, and coastline shape, creating complex patterns that vary from place to place, but always return to the same underlying cycle. On rocky coasts, tidal pools form miniature worlds, isolated briefly and then refreshed, supporting life adapted to constant change. On sandy shores, waves and tides together sculpt shifting landscapes that never quite settle. For humans, tides have long provided a sense of timing and reassurance. Long before clocks were common, coastal communities measured days and seasons by the water's movements. Fishing, travel, and rituals aligned with tides, embedding lunar rhythms into culture and language. Even now, many people find comfort in watching the sea advance and retreat, a motion that feels purposeful without being urgent. The regularity of tides offers contrast to the unpredictability of weather, reminding observers that some patterns remain steady regardless of surface conditions. At night, under moonlight, this effect deepens. The water glints and darkens, moving almost imperceptibly, until it suddenly becomes clear that the shoreline has shifted. Rocks that were dry now glisten. Sand that was exposed is submerged. The change is gradual enough to feel calm, yet constant enough to be undeniable. The moon does not command the ocean. It invites it to respond, and the ocean answers faithfully. This call and response echoes other exchanges seen throughout the planet. Forests exhaling moisture, soil recycling matter, magnetic fields guiding particles, all operating through relationships rather than control. Tides also connect to cycles of rest and activity. Many animals, including humans, show subtle responses to lunar phases, though these effects are often gentle and easily overlooked. Light levels at night change with the moon, influencing behavior and sleep patterns. Coastal species synchronize reproduction and feeding with tidal schedules, alternating between exposure and immersion. The planet itself seems to settle into a slower pace under the moon's watch, nights feeling quieter, movements more measured. This is not mysticism but physiology, and physics intersecting light and gravity shaping experience. The moon's distance matters too. It is far enough away to create a broad, gentle pull rather than sharp, disruptive forces. Over geological time, the moon has been drifting slowly farther from Earth, lengthening days by fractions of a second and subtly altering tidal patterns. Even this change is gradual, unfolding over millions of years, allowing life and systems to adjust. The lullaby continues, slightly altered in tempo, but never stopping. To listen to the tide is to listen to the planet remembering its place in space. Each rise and fall is a reminder that Earth is not isolated, but part of a larger dance, influenced by companions near and far. The sea breathes in and out, not with lungs but with gravity, responding to a presence that circles patiently overhead. As waves lap higher and then withdraw, as currents shift direction and then return, the rhythm persists, steady enough to trust, slow enough to soothe. It does not rush toward an end or begin anew each day. It simply continues, carrying coastlines, creatures, and quiet observers along with it, offering a pattern to rest within, a motion to fall asleep beside, as the moon keeps watch and the ocean answers again and again in the dark. Even after chaos, the planet returns to quiet creation, not by erasing what happened, but by building patiently on what remains. After tides rise and fall, and the moon keeps its steady watch, the story stretches backward into moments when Earth was forced to change more abruptly than usual. These moments are often described as endings, but on the scale of the planet they are pauses, deep breaths between long stretches of becoming. Earth has never been fragile in the way we understand fragility. It bends, reshapes, reorganizes, and then continues, carrying traces of disruption forward into new forms. Ice ages have come and gone, not as sudden freezes, but as slow advances and retreats driven by subtle shifts in orbit, tilt, and sunlight. Over tens of thousands of years, glaciers spread across continents, lowering sea levels, exposing land bridges and reshaping ecosystems. Forests retreated, grasslands expanded, animals migrated or adapted, and some disappeared. Then, as conditions shifted again, the ice receded. Water returned to valleys. Life followed. What emerged was not a restoration of what existed before, but something new, shaped by memory and modification rather than repetition. Each ice age left behind landscapes softened and reordered, lakes carved by ice, fertile soils ground from rock, coastlines redrawn. The planet did not rush to recover. It allowed time to do the work, letting meltwater flow, vegetation spread, and climates settle into new patterns. Even more dramatic were moments when Earth encountered forces from beyond itself. Asteroids and comets have crossed its path many times, most passing unnoticed, some striking with enough energy to alter the course of life. The impact that marked the end of the age of dinosaurs was not the planet's first collision, nor its last. When such an object strikes, energy is released on a scale difficult to imagine, vaporizing rock, igniting fires, and sending dust high into the atmosphere. For a time, sunlight dims, temperatures shift, and ecosystems falter. Many species vanish, unable to adapt quickly enough. These events are often framed as catastrophes, and for individual organisms they are. But for the planet as a whole, they are transformations. After the dust settles and conditions stabilize, life returns, not timidly, but experimentally. New species diversify into open niches. Forms that were once minor become dominant. Mammals, once small and nocturnal, expanded and evolved after the dinosaurs disappeared, eventually giving rise to a wide range of creatures adapted to nearly every environment. The planet did not choose this outcome. It allowed it, providing space for change to unfold. Mass extinctions punctuate Earth's history, marking boundaries between eras, yet none left the planet empty. After each one, life reorganized, drawing on what survived, recombining traits, and exploring new strategies. Coral reefs collapsed and reformed. Forests vanished and returned in altered forms. Oceans changed chemistry and then found new balance. Even the greatest losses became starting points, not through intention, but through persistence. Life continued because conditions allowed it to, and because the planet remained dynamic rather than static. Volcanic episodes too have reset environments repeatedly. Massive eruptions have covered regions in lava, releasing gases that alter climate and ocean chemistry. For years or centuries, conditions become harsh. Then the eruptions cease, lava cools, weathering begins, soil forms, plants take hold in cracks and crevices. What begins as barren rock slowly transforms into living landscape. The Hawaiian Islands offer a clear example of this cycle, where new land rises from the sea, initially sterile, then gradually colonized by wind-blown seeds, birds, and insects. Over time, forests grow, erode, and eventually sink back beneath the waves as tectonic plates carry them away from volcanic hotspots. Creation and destruction are not opposites here, but partners in a long process. Even shifts that feel destabilizing from a human perspective, changes in sea level, temperature, or atmospheric composition, are part of Earth's long pattern of adjustment. The planet does not maintain equilibrium by holding conditions constant, but by allowing variation within bounds that sustain ongoing processes. When one pathway closes, another opens. When one form fades, others emerge. This resilience is not a promise that everything remains comfortable or familiar, but that complexity persists. The beauty that follows upheaval is not ornamental. It is functional, the result of systems finding new ways to cycle energy and matter. Forests growing on glacial till, reefs forming on submerged volcanic rock, grasslands spreading across former seabeds. All of these are expressions of recovery without nostalgia. Earth does not attempt to recreate the past. It builds forward, using what is available. Over deep time, this has produced increasing diversity, intricate interdependencies, and landscapes that feel layered with meaning even when they arise from simple rules. The quiet after chaos is not emptiness, it is preparation. During long, stable periods, ecosystems refine themselves, developing resilience through diversity and redundancy. So when disruption arrives again, as it inevitably does, something remains to carry the system onward. This pattern can be seen everywhere, from soil communities rebuilding after fire to forests regrowing after storms, to oceans rebalancing after shifts in circulation. On the longest timescales, even continents collide and separate. Mountains rise and erode, and yet the surface never becomes monotonous. Variation persists because change is continuous, not because stability is enforced. To think about Earth's resets in this way is to soften their edges. They are not punishments or failures, they are adjustments, sometimes abrupt, often slow, always followed by continuation. The planet does not hold on to disturbance longer than necessary. It absorbs, redistributes, and moves on, allowing new patterns to settle. This capacity to return to quiet creation after upheaval is not dramatic. It is gentle. It unfolds over spans that exceed individual awareness, but it is steady. Even now, the planet carries scars of past events in rock layers, fossil records, and magnetic signatures, yet these scars coexist with thriving systems above them. They add texture rather than detracting from beauty. In this way, Earth's history reads less like a series of tragedies and more like a long narrative of adaptation. Disruption creates openings. Openings invite exploration. Exploration leads to new balance. As night settles and attention drifts, it can be comforting to remember that the ground beneath, the air above, and the water nearby are part of a system that has endured far more than any single moment. The planet has reset itself many times and still become beautiful, not by clinging to what was lost, but by allowing what remains to grow into something unexpected and quietly enduring. As everything we've wandered through slowly settles, it becomes easier to feel how none of this was ever separate from you. The drifting continents, the patient rivers, the breathing forests, the quiet work of soil and ice, all of it has been happening around you and within you at the same time. Your breath follows the same patterns as the ocean, in and out, steady without instruction. The minerals in your bones were once part of mountains that rose and softened long before memory. The water moving through you has passed through clouds, leaves, rivers, and deep stone. You are not visiting this planet. You're participating in it, moment by moment, without needing to do anything special at all. It's okay if some of the details begin to blur now. Facts were never meant to be held tightly tonight. They were only here to open a door, to give your mind something gentle to rest against before letting go. The Earth does not ask to be remembered perfectly. It continues whether it's noticed or not, cycling quietly through time, adjusting, flowing, breathing. Somewhere ice is inching forward in silence. Somewhere a river is bending toward an easier path. Somewhere roots are exchanging messages underground, and plankton are lifting oxygen into the air without sound. And here, right where you are, your body is doing what it has always known how to do. Softening, slowing, repairing. You don't need to stay awake for the ending. There's nothing to miss. The story keeps going without attention, just as it always has. If thoughts drift, let them. If images fade, let them. Calm doesn't need to be held in place. It settles on its own when given room. Tonight, you can rest knowing the ground beneath you is steady in its motion. The sky above you is wide and patient, and the planet you belong to has carried far greater journeys than this gentle moment. The facts can fade, but the calm can stay. And as sleep arrives, quietly and without effort, you are exactly where you need to be, part of a world that knows how to continue softly through the dark.